In this segment, we are going to discuss about moving coil galvanometer. Moving coil galvanometer is a device which is used to detect the presence of current. Its principle is that a current carrying coil experiences a torque in a magnetic field. It consists of a coil with many turns free to rotate in a uniform radial magnetic field. Later on we will see what is the importance of radial magnetic field. Suppose current I is passing through the coil, then the torque experienced by this coil is tau equal to NIAB sin theta, where n is the number of turns. For radial field, theta is equal to 90 degree, so tau equal to NIAB. This torque tends to rotate the coil. A spring SP is here provides a counter torque, that is tau dash equal to K phi, which balances the magnetic torque NIAB. Here K is a restoring torque per unit twist, also called the torsion constant, and phi is angular twist per unit deflection. So in equilibrium, K phi is equal to NIAB, or phi equal to NAB by K into I. See, for a given galvanometer, this term is constant one. Means we can say phi is proportional to I. That is, deflection of coil is directly proportional to the current flowing in the coil. So it is up to the working of moving coil galvanometer. Now, current sensitivity, that is from this part, that is phi equal to NAB by K into I, phi by I equal to NAB by K. This is called current sensitivity of the galvanometer, means deflection per unit current. Similarly, voltage sensitivity, that is deflection per unit voltage. So here Vs equal to phi by V, and we know V equal to IR. So phi by IR, also phi by I is current sensitivity, so current sensitivity by R, or it is NAB by KR. Another very important term, figure of merit or galvanometer constant. Current which produces a deflection of one scale division, means that much current which produces one scale deflection, that is called galvanometer constant or figure of merit. So it is I by phi, current per unit deflection. So we can say it is reciprocal of current sensitivity. Now the function of soft iron core. Soft iron core having high permeability, due to which it increases the strength of magnetic field, that is B, and hence increases the sensitivity of galvanometer. Now the radial magnetic field. For the radial magnetic field, theta equal to pi by 2. So the torque is maximum. And also this makes deflection proportional to the current, and hence increases the sensitivity of galvanometer. Next is conversion of a galvanometer to ammeter. We know ammeter, which is used to measure current, and the resistance of ammeter is negligible. So galvanometer can be converted into ammeter by shunting it with a small resistance, means by connecting a small resistance parallel to the galvanometer. Now let us see, if I current is coming and IC current is towards the galvanometer, then from the Kirchhoff's junction rule through the shunt we can say I minus IC current. But the potential difference across galvanometer and shunt resistance, that is the same. So potential difference across shunt, that is current into resistance, so it is I minus IZ into S equal to IZ into G, which is the potential difference across galvanometer. And from this S equal to IZ by IZ into G by I minus IZ. So from here in the denominator we can take IZ as common and it will be I by IZ minus 1. So this IZ and this IZ got in the numerator and denominator got cancelled. So this value will be G by N minus 1, where N equal to I by IZ. And the resistance of ammeter to here, this combined as act as an ammeter. So its resistance, these two are parallel, so 1 by resistance of ammeter is 1 by G plus 1 by S. And now how a galvanometer can be converted into voltmeter? A voltmeter having very high resistance, so galvanometer can be converted into voltmeter by connecting it with a very high resistance. Now the current through the both, that is the galvanometer and this high resistance, will be the same, but the potential difference across the given load resistance is sum of the potential difference across galvanometer and potential difference across the high resistance. So this V equal to IZ into G plus R. G plus R is the total resistance in the circuit, or R equal to V by IZ minus G. So it is the value of R. Another way to find the value of R, this V equal to IZ into G plus R can be written as IZ equal to VZ by G into G plus R. So V by VZ equal to 1 plus R by G. If V by VZ is N, then N equal to 1 plus R by G, where N equal to V by VG. Thus R equal to N minus 1 into G. If we compare here, that is shunt equal to G by N minus 1 and here R equal to N minus 1 into G. To keep in our mind, shunt is a small resistance, so G is divided by N minus 1, where R is high resistance, so it is multiplied with N minus 1. But in conversion of galvanometer to ammeter, N equal to I by IZ, and IZ is the current which produces maximum deflection in the galvanometer, and the resistance of this voltmeter will be resistance of galvanometer plus the high resistance. Thank you.